Hello, my name's Richard Bishop. I'm a lead quality engineer at Lloyds Banking Group in the UK. And today I'm going to be talking about our journey towards improving our test automation using Jenkins. So first of all, I'd like to welcome you to the Vivid and Unicom virtual community days. We're focusing on agile, DevOps and testing, and these sessions are going to be shown between the 1st and 4th of December. By joining this, you've become a Vivid member, I'm pleased to say. Membership is free, but what we would urge you to do is log on to your Vivid profile online and tell us what you're interested in. If you do that, we can make sure that we try and ensure that you get content that is relevant and related to your interests rather than things that perhaps might not be as relevant to your interests. So we're keen to make sure that we give you what you want as a Vivid member. So first of all, I'm going to talk about test automation, a little bit of background about how I got involved with using Jenkins for test automation, look at ways that we can use automation to reduce the amount of time spent testing, a little bit of background around what Jenkins is and how it's particularly useful to testers. So first, I'll talk about why testing seems to take so long. And if you look at this slide here, you can see from the top, it's basically two rows. So top left, you've got requirements gathering, perhaps a little bit of software development using a stub on a server, and then checking in code and doing a build of your test environments and so on. And then all those different types of testing. On the bottom row, we're getting closer to production. So you're doing things like performance testing and final verification of application performance, and then monitoring that application once you're in production. One of the problems with this is at each of those changes, either in the environment that we're talking about or the type of step that we're automating, you're going to have handovers between different teams, and those involve little button presses or phone calls to ask somebody to kick off a batch job or do whatever might be needed, and that can obviously introduce delays and dead ends and stops and U-turns within your project, and that's the thing that's hard to manage. So at Lloyds, we already do lots of automated testing, and levels of automation are increasing, but we do still have some of these little bottlenecks. So over recent years, what we've been doing is trying to get rid of those by automating, and we've done a pretty good job of this, but there are still things that we need to do to try and improve things. And I'll talk a little about the journey towards those sort of improvements that we've been making over recent years. So this slide basically introduces a traditional way of testing, and one way of trying to speed up this software development and delivery process is to automate some of these automated steps. And what I mean by that is a lot of the things on this slide are button presses. They are somebody doing something, and those things are already automated. And what we need to try and do is take away the manual button press and automate the processes that are needed to, for example, build a new environment or start a functional test. So there's a slightly simpler version of a project here where you've got multiple different stages, starting off with a change to the user interface, maybe a database change, those sort of things, a bit of new functionality being added. And typically those would be rolled together into a build that would then be deployed and tested. One of the ways that you can use Jenkins to improve this is by doing lots of little tests or automating those tests at the end of each of those little phases. And that obviously is part of the whole shift left narrative that people have been talking about for some years now. And this is something that we've been doing for some time. But we've recognized it still has limitations, and we've done quite a few things to improve on this type of testing. Automated though it may be, we know we can do better. So ways that Jenkins can help testers, and I've already alluded to some of these. In a way, this slide's here just so I don't forget to mention something. So I've already talked about automating automation. One thing I haven't yet mentioned is performing conditional tests. So that could be something like a trigger that says, has a deployment done? If so, run a test. Has a functional test passed? If it has, then okay, we're happy, we're confident, let's go on and run a performance test. It's pretty good at showing test status and trending information. You can see an example on the right hand side where we've got a particular build job, and you can see it over time whether or not it passes or whether it fails. The other thing you can use it for is, rather than having a conditional trigger, you can have a trigger that happens perhaps on a daily basis. So you could have daily test environment checks that make sure your test environments are up and ready for your testers as they come into work. So you could run something every morning, for example, to check things are running as they should be. So this asks the big question, haven't we heard all of this before? And in many ways, yes, that's true, we have. 2017, I did a very similar presentation to what I've just shown you, talking about Jenkins in the testing lifecycle. So how we were incorporating automation into those tests that traditionally had been done manually by different test teams. A year later, I did a talk talking about expanding on that and talking about more automation using Jenkins for a Vivid special interest group talk. And if you look on, I mean, I did a quick search on SlideShare for this, and I found loads of slides going back to about 2014 explaining how to automate your testing using Jenkins, using various different tools. There were things from Soaster, there were things from Selenium, Source Labs, all sorts of different people. And so this isn't particularly new. So as this slide shows, yes, we have heard of all of this before. So rather than talking about what we've done in the past, let's talk about some of the things that we've started to do differently to those things that I've outlined on the earlier slides. And the thing that started all of this off was a challenge set to me and some colleagues by my boss at Lloyds Banking Group. He asked us to look into developing a shared library to build automated test pipelines. The idea being that this shared library of code and useful functions, for example, could be shared by developers and testers throughout the banking group, and more people would be able to embrace this type of test automation. The idea is obviously to simplify the handoff between different teams and different test tools, and also define tests as code rather than as static assets. So rather than having a series of tests that don't change, we try and automate some of that updates of tests and test scripts and test data, for example, so that things are always up to date and can pretty much run on demand whenever required. So there are a variety of ways that we were asked to look into this, and the pipeline that we've started to develop has got dozens of gates between different tests. You see in the top left-hand corner, you've got check into version control and a build, and then unit test, deployment, and other types of tests. The idea is that each of those stages can be defined as a quality gate within a particular pipeline in Jenkins and run ideally without supervision. So that's what we're working towards. And some of the things that we've started to incorporate are, as well as obviously version control, improving the branching strategy that developers and testers use, incorporating things like static code analysis, vulnerability scans, all those different types of things. So the key thing for this is to try and avoid people working in silos. So you'll remember from the slide earlier where we've got people pressing buttons in between handovers between different areas. It's what we're trying to avoid. And this picture shows it quite clearly in that you've got someone who's done their commit and then they're sitting there and they've nothing to do. And then the static analysis is done and then a team is asked to do deployment and so on. And the idea is that we're going to try and break down the barriers between those teams so there's better visibility between those teams. Everybody knows the status of the code development or deployment or how the project's going. And ideally, we'll automate everything from that initial requirements gathering at the start of a test to the test report at the end. So our quest, as I've already alluded to a little bit, was to take a test approach, look at the tests that are typically run within that test plan, and look at the end of test report and work out everything that we could automate from the left to the right-hand side of that screen. The idea being that if we know a particular component within an application is going to change, we can focus our efforts on testing that, ideally automate as much of that testing as possible, and simplify the testing. So only do the testing that's absolutely essential, rather than testing everything every time, and adopt a sensible approach to our planning and test reporting. So the idea is, based on the components that are going to change within an application, we determine the things to test, and that develops a test plan automatically. We then do the code commit, and the appropriate tests relevant to the changes that I've just described are then run. And then we gather together all the results and produce an end of test report. So the idea of automating that right from the start to the end is quite a challenge, which is why I added this little picture in the top corner. I likened it really to the quest for the Holy Grail. It's not easy, but hopefully I'll be able to explain the journey that we've taken towards this ultimate goal. So first of all, I think the thing that was crucial to us was to have a multi-team approach. This isn't something that you can do on your own. It's not something that a small team can do. You really need to try and pull in resources from lots of different areas to make sure you've got the relevant skills to help build this type of code library that ultimately can benefit lots of different teams. So, as I've already mentioned, I work in the quality engineering team. That's down in the bottom of this slide. But we work very closely with two other areas. So within Lloyds Banking Group, we have this concept of centres of excellence. These are areas of specialists who work on different technologies and share their experience throughout the group, so as many people as possible can benefit from those specialisms. So on the left, we've got the Software Engineering Centre of Excellence. They brought a whole load of skills to our virtual team, including much better understanding of source control than I certainly had when we started this work. They also advised on using Jenkins files and writing our tests as code rather than as static assets that are stored somewhere. And they've done a lot of work with the automated reporting. Quality engineering, that's the team I work in, as I've already said. Our key areas are supporting test tools and making sure that we as a bank get our best value from the tools that we've invested in. Those can be tools that we've purchased, things like UFT, LoadRunner, those types of tools, but also tools that are potentially open source, things like Jenkins, or some of the more niche tools that we've started to use. And then on the right-hand side, the DevOps team, they brought a whole load of skills around repository management, things like GitHub. They've helped us with that. They also bring skills like server provisioning, automated builds, those types of things. And so the three teams have effectively worked together on this. So when we first wanted to try and describe this to people within the group, we found it quite hard to build an analogy that described it. And first of all, we started off by saying it's a bit like a jigsaw puzzle. We're trying to give you the pieces so you can build a puzzle. But then we thought that doesn't really work. It's not a very good analogy, because whilst we've got lots of different tools and they all fit together in different ways, it's not a particularly good analogy because they can only fit together the same way. It's not possible to use the wrong piece in the wrong place. So we came up with a better analogy, we feel, which is describing these units of code and these libraries as building blocks that help people to get what they want from a test tool. So this is an example of a pipeline which goes some way to illustrating what it is that I've been trying to describe over the last 10 minutes or so. So first of all, you do a commit of code into GitHub or some other source code repository. That can either be a main trunk or a branch within that repository. And in doing so, you will start this whole workflow, which runs from left to right in multiple different stages. And I'll describe those in a little bit more detail. So first of all, we have this thing called a Jenkins file. So when you do your check-in, that includes a Jenkins file, which describes the changes you've made to the code, as well as the tests that you'd like to run. So the Jenkins file defines not only the location that the tests need to run, but any dependencies like test data, test environments, all those types of things. And as the Jenkins job starts, it collects all those dependencies together before moving to the next stage. And in this case, there's a little screenshot there showing this working for real at Lloyd's. So you can see we do the checkout of code. In this case, we've run a lean FT. Sorry, we've loaded some dependencies for lean FT. We've done some code analysis using SonarQube. Once that's passed, we've gone past the quality gate, and the next thing is to run the next type of test. In this case, one running lean FT, which is now known as UFT developer. So the tests run, and then we publish the test results. To go into that in a little bit more detail, I'll show what happens. So effectively, the developer or tester pushes a change into GitHub, and that triggers a webhook which tells the Jenkins server that a change has happened. And that is the thing that triggers the multi-branch pipeline job, which runs in Jenkins. So Jenkins knows then that it needs to go back to GitHub and get the project repository down into Jenkins. And in doing so, it then processes the Jenkins file, which tells it what library functions are going to need to be run to do these tests. So it pulls those again from GitHub and builds a new job. It then sets that job to run on an agent, as you can see there. And that agent also gets its code from GitHub. So basically, you've got one place to store all your assets, and they're managed dynamically. In this case, the Jenkins agent may pull some dependencies from some other repositories. We use Nexus, for example, to pull the libraries that need to run a test. And as those tests run, you can see we go through the various quality gates. In this case, running a functional test using lean FT. And once that finishes, those test results are then pulled back to Jenkins and are visible to whoever wants to see them. The thing in the bottom right-hand corner is a screenshot from lean FT or UFT, so you'll be familiar with that if you're a user of this software. Those results are then pulled back to the server, and I'll just go into a little bit more detail here, and we'll just look at some of the code that's behind all those types of functions. So this is a screenshot of my IDE. It's Visual Studio Code. I quite like it because it's got source code management built into it, so it won't let me forget to commit after I've made a change. So what you can see if you look into my workspace is there's a thing defined there called Jenkins Lib, and that's a project within GitHub that holds our Jenkins functions, our library. And within that, you've got all these various different files that contain the code required to run tests. There's 3 examples there. There's one for lean FT, one for Performance Center, and one for Selenium. But we've got a whole load of these different files that describe how to run tests, or tell Jenkins how to run tests when we want them to. And then down at the bottom, there's 3 examples of projects which, if we were to drill down into those, you could see contain Jenkins files describing the tests that should run. So if I look at a sample library file, this is a Selenium one. Up at the top, you can see a definition of all the different helper files that contain the code which is needed to support the different tools that we're going to use in the tests. It also includes a definition of where a test is going to run. So in this case, it's going to run on a Jenkins agent with a Selenium label. So it will only run where that code is already installed. There's an option that I've not discussed there, which is how's this going to be triggered? In this case, it's a push of code to GitHub. And you've got then these various different test stages which are optional. And as you may have seen on the earlier slide, you have a label associated with each of these. And so when you see the test running Jenkins, the labels are effectively the column headings, so you can see how far through a series of tests a project is going before it encounters problems. So if we look at a Jenkins file in a little bit more detail, one of these is committed with every project. So in this case, all we're really passing in a Jenkins file is some details about the type of testing that we would like to do, the name of that test, and some details associated with it, which are just passed as variables. So in this case, it's a Selenium script running in Source Labs. It's got our Source Labs credentials, which I've blocked out so you can't read them, and the details of the project that we potentially want to test. So some of these Jenkins files can be really small, very little information in them, and then others, like the one below, got a bit more detail in it. This is an example of one where we run a test based on assets that already exist within Performance Center. So this is using the well, it's called HPE Application Automation Tools plugin. I think it's been renamed Micro Focus now, but these plugins basically, this Jenkins file tells Jenkins which plugin to use and which parameters to pass into that plugin in order to run a test. In this case, it's running a test ID 7 in a project called SDLC2. This is my demo project effectively. And there's various different settings defined within that Jenkins file. One of the things that we're really keen to do is put lots and lots of comments in these files, because the idea is that we're giving an example of code that will do a certain thing and passing it over to people who perhaps aren't as familiar with these libraries as we are. So we put lots of code, comments in the code to advise people on how to get the most from our code libraries. And then the next thing we had to do is encourage teams to adopt these new processes. They are new ways of working. There is a learning curve that you need to go through to adopt these different ways of working. And so there's a certain amount of hand-holding that we as a central team have had to do. The easiest way is that we share all our libraries using GitHub, so people can take copies of those. They can also submit changes and improvements to those if they want. So we're trying to build that collaborative way of working across multiple teams. There's no point having two teams in two disparate areas of our bank both working on the same problem. And part of what we do is identify problems that multiple teams are likely to face, and then we can work on them together. One of the things that's worth mentioning is tests can be run based on a trigger. In this case, we've got an example where this GitHub, the webhook is going to tell us when a change has happened, and the test will be triggered on that. But you've always got the option to build now. So moving to this way of automating your tests it's not a one-way street. You can still have that. If you want to be able to press the button and run a test manually, then you can. And obviously this is particularly useful if you're debugging or you want to run an ad hoc test, for example. So this next slide shows you in a bit more details an example of some of the outputs. So the details of the changes or the commit message are held in that field there where it says no changes, because this is obviously a test that ran manually. But if you've done a commit, your commit message would appear there. So it's useful. You can see what commit resulted in what series of tests, and then go back to the developer, for example, who made the change, or the tester who made the change, and pick up any problems that are identified as a result of that commit. The stages I've already covered. These are the things that are effectively like column headings in this report, but that is defined as stages within the Jenkins files. Within Jenkins, you've got the option to drill down into your tests. So there's a whole load of information there. You've got this console output, which is a text-based report as to what happened. And that effectively is everything that you would see if you were watching the console as a test ran automatically, is reported back to Jenkins. And the other thing you've got here is, depending on the test tool, the test results are pulled back into Jenkins. So you've got those associated with the information around the tests that ran. The next thing that we're working on is taking those test reports and pushing them into GitHub pages, so that we've got a permanent and secure repository for test results. which is useful for reporting purposes, as well as audit. You know, we have audit requirements to make sure that test results that prove a certain thing are kept securely, and so that's the next thing that we're working on. You've always got the options to pull these things down from Jenkins as zip files as well, and we've also done quite a bit of work integrating Jenkins and ALM, for example, and doing that sort of work. So to be honest, as I was saying earlier, we're providing people within the bank the building blocks to do this, but how they choose to put them together is to a certain extent up to them, and depends on their project requirements. So here are some examples of the code that we've shared internally at Lloyds Banking Group. So there's UFT Developer, Veracode, Source Labs. I mean, I won't read the list, but you can see there's a variety of functional performance testing tools and so on there. We're working now on incorporating mobile testing into this as well, using UFT Mobile and Appium. And as I mentioned on the previous slide, we're looking to automate reporting into Git pages, which is a sensible place, because it means that we can effectively store all of our test assets, from test approach, the test scripts themselves, the application code, all the way through to the test results, all in the same secure place. So the next question is, how far is there to go on this journey? I've described a journey a few times, and when I found this graphic and put it into a slide, I literally had no idea where to put the car, simulating where we're moving on this journey. It's really hard to say. So my search for a snappy graphic to try and describe how we were doing has probably asked more questions to me than I've been able to give answers. The simple answer to how far is there is, well, we don't know, to be perfectly honest. What we do know is we're far more automated than we were before. We know that we still have a long way to go improving what we have, adding support for different tools and ways of working, as well as training other people up on how to get the most from these different testing techniques. One thing that is happening is, because we're automating more, that automation is freeing up time so that developers and testers have got more time to work on other improvements. So it's one of those things where we're getting better at it, but as we're getting better, we're finding more things that we can improve. By finding those, so it's almost like a never-ending road. All I can say is that we're moving down it and improving things as we go along. So yeah, in reality, we'll probably never finish this journey. And whilst that road looks simple, there will no doubt be dead ends and U-turns and things that we have to make as we go along. But hopefully this presentation has helped inspire you to make similar improvements to your companies and your approach to testing. And if you've any questions, I'd be more than happy to answer those, either in Slido, which is online at the moment. I'm happy to answer questions live, or alternatively, if you want to get in touch via Twitter or LinkedIn or some other means, I'd be more than happy to hear from you. So thank you very much. I'd just like to remind you once again, thank you for joining Vivid, which you've done by virtue of attending this event. I hope you found it useful, and I hope you've had an opportunity to meet some of the people, either through the Zoom or various different webinar sessions, or through the Verbella virtual community. So I hope you've met people and had value from this conference, and I look forward to hearing from you if you have any questions. So thank you very much.